Friction. When you hear the word, what comes to mind? Fire and heat? Slippery slides? Hopefully not this image. So what exactly is friction and how does it apply in the real world? Let's enter the friction zone and learn a little more about friction and how it applies in physics and in our day-to-day lives. Before we dive into the concepts associated with friction, let's start with the basics. First, it will be helpful to note that friction opposes the movement of all objects. Let's say, for example, you're pushing a box up a ramp. Friction in this case would be acting towards you in the opposite direction you were trying to move the box. This means that friction hinders the movement of objects. Let's hope it's not a heavy box, or else friction will give you a run for your money. But we'll discuss that now. So how do you increase the amount of friction acting on an object? By adding more mass to it. While the amount of friction an object has acting upon it is dependent on an object's mu, the coefficient based on the material of the object, it can also be based upon an object's mass. Therefore, as depicted in this demonstration, the more mass an object has, the more normal force the object has acting upon it. Therefore, the more friction that object will have opposing its motion.
Friction is also the reason why I'm able to hold this block of glass in between my hands. I'm applying a force on each side of the block with my hands, which increases the normal force that the block is pushing out to my hands, and therefore increasing the friction that is acting against gravity.
This statement is proved by the following equation. Force of static friction is equal to mu times the normal force acting upon that object. Did you know friction can be related to sound? Well, it can. If I'm in the desert in Egypt dying of thirst and you're in the United States, you can't hear my cries for help, can you? Of course not, but why? Well, the answer is friction. Friction is the reason sound waves dissipate as they travel. They can only travel a certain distance in their journey because friction eventually causes them to fade out. Okay, so what about electricity? Have you ever wondered why a light bulb doesn't shine as bright as it should? Well, once again, the answer is friction. All light bulbs are considered resistors and, therefore, hinder the flow of electrons in a closed circuit. This is actually a good thing, though, because without resistors, electrons could flow without hesitation in circuits, leading to very shocking situations.
Friction is the reason why I can stand up in this picture. Friction is keeping me standing still because I'm applying a force to the column, which is applying a normal force to me, which is pushing me to the right of the screen, but the friction at my feet is pushing to my left, keeping my feet still, and friction is also keeping my arm still against the column because it is pulling my arm up while gravity is pulling my arm down, keeping that still as well.
But how does friction relate to energy? Well, friction generates thermal energy. But of what importance is thermal energy? Thermal energy is normally energy lost in the form of heat. Because mechanical energy refers only to kinetic and potential energy in a system, a loss of energy in the system will most likely occur if friction is present due to the creation of thermal energy within that system.
There are two types of friction, static and kinetic friction. Static friction is typically a lot stronger than kinetic friction because it requires a lot more force or more energy to get an object to start moving. This is why in this video you can see that when Annalie drops the weight, the block starts to move and then quickly accelerates across the screen because it overcomes static friction and then overcomes kinetic friction, which is a lot less than static friction. In this final demonstration, we can see the difference between a cart and a block of wood going down a ramp. As you can see, the block of wood relatively stays still while the cart goes down the ramp with ease. This is because the amount of friction on the block of wood is much higher than it is on the cart.
Thanks for watching, and we hope you learned a lot more about friction today.